Hello? Okay, needs to be a bit louder. How's everyone doing? It's my first time kind of meeting you all, because I think we've had 2 lectures together, right? Anyone watch lectures? Maybe? Yeah, 2 online, which has been good. That looks better. So, we're going to have some fun today. Who watched the online lecture from Tuesday? Hands up. Okay. Bunch of you. That's lovely. All right, well, just as we get started, wanted to properly say hi. I kind of just jumped into things online. I think we will be together a few more times this term. I think next week, week 7 as well, something like that. So get used to me, put up with me, all of that. Really quickly, I don't remember how much I did contextualize things last Tuesday, but I just want to add it now that we've gotten into some things a bit. My background is in software engineering. What I do day to day in general is run a startup company. And the reason I think this is worth pointing out is because there are some pros and some cons of that. One of the pros is that I basically literally run an organization that's pretty much like a software engineering company. The cons of that is that the organization's 20 people. That's not a very large company. I've worked at large companies. I've worked at Microsoft. I've worked at Dolby Digital, things like that. But my company itself is quite small. And that's important because I would encourage you to, pay attention to, I guess, some things I say throughout the term. But do remember, of course, that, I don't have 20 years of experience at CommBank or something like that, because that is a slightly different thing. So I'll generally gravitate a little more towards chaos and action than, I guess, the same degree of carefulness that you'll see at larger companies. But that's just a little bit of fun. If you do have questions about any of that, I'm always happy to answer them, always happy to chat about work or anything like that. I found last term with 1531, I brought up like a Slido during the lecture, but no one commented on it, which made me really sad and kind of awkward. So I'm not going to have a Slido up this term when we do stuff in person. So if you do kind of have questions and you don't want to put your hand up, which is totally fine, I don't like putting my hand up because it's awkward. You can just go find the YouTube video on the course website and just post a comment on the YouTube video, because I'm just bringing that up now and I'll be having a look at those throughout the lecture. So if you're feeling a bit shy, that's the way to do it. Yes? Was there nothing shared about that or anything, or I'm not? Yeah. Oh, okay. Yeah, I don't know much about that. I just kind of turn up and do these lectures, but a recording has been shared, right? Yeah. Yeah. So that's a great question. So if the recording's been shared, that would be the video. Linting as a topic has not changed in that time. So I love that you're asking about the relevancy of it, because that is a good point, as you wouldn't want something that's like particularly old or anything like that. But yeah. The cool thing about linting is that it's a really basic idea too. It's kind of true for any programming language. Obviously, Yuchao would have gone and talked about this in some detail. So I'm just getting the YouTube video up. But it's not liking me today. But it's cool because it's the same with every language basically. I've taught courses on C++. I've taught courses on what else is it called? JavaScript, but for front end. I've taught courses in C. Every different language has got its own linting. And I think as well, I know that you all know this because again you did the lecture on it, but linting, we often talk about it like it's a there was style. It's an easy way to keep style, which is true. But I think a really important point about linting is that good style reduces bugs. And I don't think that one is usually emphasized as much as it probably could be, at least from what I've seen, because code that's clean, if everyone knows what code should look like, they'll spot problems in code much quicker. And linters do, even without TypeScript, still pick up on a reasonable amount of problems, because linters, they can't tell things whether, because if you think about a linter compared to, how would you say, if you think about TypeScript compared to a linter, they both follow the same idea, which is that they both basically look at code before it runs and they break it down and see if there's any problems with it. Linters, in a way, are probably just much simpler versions of it. Because if you think about a linter, one thing it does do is that if you use a variable that you haven't declared, it will actually see that and point it out, you know? But nothing would stop a linter noticing that you have a string and an int, and like then you add the two together, but that doesn't work, right? Like the linter could do that. It's just the linter kind of is like, well, this is what my job is, and I won't go any more further than that. So in a way, you could kind of imagine something like TypeScript as like a linter on absolute steroids that just doesn't check style, you know? But they all follow the exact same thing. There's a really cool course at CSE. I did it when I was an undergrad. It's like 8 years ago now or something. But it was called, like, I think, Compilers and Programming Languages. A guy called Jingling used to run it. If he still runs it, it's something you should check out and see if it would interest you. It was a great course because they basically made you take in a code file, like a string, and like parse it, like interpret it, like split it up and turn it into like an object. A little bit like, you know, like if I could say to you, I want you to write a program that is the JSON.parse function. You know, it takes in just text and it like converts it into a usable object. There's a really kind of fun course because it really makes you think a lot about exactly what's going on behind the scenes. There are questions in the YouTube chat already about, did we have the linting lecture already? I don't think so. Yeah, as far as I know, I don't know, because again, I'm not like running the course this term. I kind of just help out with the lectures. But as far as I know, I think it was one of the lectures like teamwork or something like that just went longer than normal because they added a lot more cool stuff in there. And I think that just meant they ran out of time in one of the weeks. So yeah, linting got shared by Yuchao from the impression I'm getting in a notice. And it's probably linked on the course website anyway from memory. I'm just checking because I can see the course website. Yeah, they have linked the linting recording. It is just, they linked quite an old video, so I see why people are like, that seems like a while away because it was 22. A lot of the lectures in 1531 I had a big part in writing in the early days, and a lot of them haven't changed a great deal, besides they've just gotten nicer and clearer, but linting's one that hasn't really changed, so totally fine. All right, let's get to it. Okay, so today's lecture is on advanced functions. It's a bit of a funny lecture because I don't know how to put it. So this is all about JavaScript and functions, and more importantly, I guess, like scripting language, functional language functions, and it really kind of has nothing to do with software engineering. It's one of those lectures where if the school came in and was like, this course needs to have more software engineering specific content in it, this would be like one of the first ones to go. So I don't want you to try and relate it too heavily to like the philosophical aim of like the software development lifecycle and testing and any of that. It's much more about like general programming knowledge, which is equally critical in my view, right? But it's maybe more critical in the context of your software engineering program and your, you know, holistic computer science self than it is specifically about like 1531. The reason we do teach it though is because it is actually quite useful for the project and understanding JavaScript, because a lot of you have just programmed in C before, and as part of that, there's actually a few things JavaScript does that's a little bit weird. The obvious examples, which is why this lecture is normally the other way around, I think, is like when you've used jest or when you've used express, if you pay attention, it's got some weird, funny syntax things in it, you know? Like when you first learned JavaScript and someone was like, you know, function add, and they say A and B and they return A plus B. I reckon in week 1, day 1, you saw that in JavaScript and were like, makes sense. A little bit different, but I'm following, pretty good. But then suddenly we get into the topics on jest or even express on Tuesday, and you start seeing things like this, and it's like, you're a little bit like, all right, what in the hell is that, right? Does anyone have that moment? Don't really care. Couple of nods. Thank you for nodding. So this is valid JavaScript, and we're really here today to kind of unpack what exactly is going on with that and understand the language well. Syntactically, everything we learn today is obviously going to be slightly different in different languages, but a lot of it carries over conceptually to other languages. Python pretty heavily, some of this stuff. Function syntax is very JavaScript specific. First-class functions and higher-order functions are very common in other languages. In fact, you can apply these topics to largely any programming language, at least all the ones that I've worked with, which isn't like 1 million, it's like 7. And then callbacks is a sort of JavaScript-y one as well. We'll kind of unpack exactly the relevance of that as we go. But firstly, we're going to talk about function syntax. So when it comes to function syntax, there are a few different ways that you can write functions in JavaScript. Want to unpack them a little bit. The one on the left, method 1, this is how we've written a lot of the code in the course so far. It's how we write the stub code for iteration 0. This is what was part of JavaScript when it was released in the mid-90s, right? That's how you wrote a function. I don't know exactly at what point, whether this was possible early on or whether they modified some, whether they basically released a new version of the interpreter for it. But method 2 started to gain popularity, as far as I could tell, sometime later on, between the mid-90s and the 2015 era, when people were like, hey, we can actually rewrite the sum function this way. And rewriting the sum function that way is really interesting because it basically starts to treat functions like variables, which is a really recurring theme that we're going to see in this lecture. I first probably got exposed to this at the second internship I did, and I was like, oh, it's a little bit strange. It took me a while to kind of click into that. I think what I did start to find useful about that when I first saw it was, where is it? Here. No? There. Was that you started to write code and you started to say things like, const 1 equals 1, const 2 equals 2, and then const result equals sum 1, 2. And suddenly it's like, okay, syntactically the code kind of does flow a little bit smoother, in the sense that what you've essentially reduced this to now is that you are writing some software where every time you make something, whether it's a function or a variable, you're always just saying, hey, this thing's name is that. Maybe it's a value. Maybe it's a function. Doesn't really matter, but it's a little bit of standardization, which is interesting. It also worked really well without kind of unpacking it for certain things that we'll learn about in the next slides, which will make sense. But then method 3 came along. This one is definitely more modern and I don't think works with the earlier versions of the JavaScript interpreter. But a lot of people were like, hey, this syntax here is a little bit kind of weird. Why don't we just simplify it down? And they said, well, to simplify it down, we're going to drop the function word, and we're going to add a little arrow there to the end, like that. Syntactic sugar, purely syntax, has no functional change at all on that topic. It's just that. People want stuff to be cleaner, right? Some people would argue this is a terrible idea, because now people are confused that you have lots of different methods of doing things, and some people would be like, they're really glad that they have it. But they're the 3 ways that we can play around with function syntax. Cool. There's the TypeScript versions too. Because Yuchao touched on TypeScript in week 3, all the code examples from this point in the course onwards are all TypeScript. So that example I gave in JavaScript, you'll see a lot in TypeScript now. Now, here's one really interesting nuance of the method 3 concept, the one where we drop the function and stuff. And that is, they said that, hey, if your function body, what's inside the function, is a single line and it just returns a value, you can basically drop the braces in the return statement. So what that meant was, if someone kind of came along and said, well, here's my nice little function, someone's like, hey, I noticed that your function is a 1-line function and it just returns one thing. It's just a simple function. And they said, well, let's create a little shortcut where you can drop the brace and you can drop the return. You can delete the braces and the returns. Now that works there. These 2 things are identical pieces of code as far as the interpreter is concerned. In reality, people generally bring that back up on the previous line, but it doesn't need to be on the previous line. But they achieve the same result. Now, what I find so interesting about this particular example is that it's a little bit antithetical to the idea of code should be clear, right? There's a phrase I've always loved, which is code is for humans, it's not for computers, right? We write code so other people can understand it. If we were computers, we would go and write in MIPS or binary or hex or something like that. But we're not computers, so everything here is for humans. So it's like, why are we doing that? that seems a little bit more confusing, right? I imagine a few of you see that and be like, that is not abundantly clear. Like if I showed you that like before this lecture and was like, what is this? You got 2 seconds to tell me. You'd be like, I think I kind of get it, you know? But there's a couple of counter arguments to it. One is that this actually is a lot easier to read in many scenarios. I'm not going to tell you now because we'll see the examples throughout the lecture, so just store that idea in your head. The webcam disappeared. There we go. But the other part is that in programming, a lot of the time, things do look odd and difficult to understand when we're not familiar with them. You know, and it's a really hard line to figure out because in this particular case, is this hard to read because it's fundamentally hard to read, or is this hard to read because you haven't seen it before? Interesting open question, always kind of worth thinking about, I would say. Now, if I jump back to, actually, sorry, I'm just going to try and, I think the stream quality looks really low. Let me just jack this up. Hello, how are you? That's good. Cool, so we'll talk a little bit more about that, but it is very short with the syntax. Now, let's take a more meaningful function, because I don't like these A plus B examples because they are just kind of a bit, you know, BS, right? But we've got this one here called many string 1. And that's in like function syntax 1, where we say function, function name, and then we got the brackets and the arguments, and then things come down to the bottom, we got the console log. I believe you've seen this before because I think it's in the TypeScript lecture, right? Yep, okay, couple of nods, bunch of people being like, I don't remember. How would we turn this into function syntax 2? Well, it's pretty simple. Instead of saying function many string, we would say const many string equals function, like that. Move it across that way. How would we turn it into function syntax 3? Well, we would drop the function. We would add the arrow to the side there, like that. OK, so pretty straightforward conversion from A to B to C there. And we can't reduce this to one line, because the rule for reducing stuff to one line is to be if it's a one-line function. But there's many lines here. In theory, yeah, sure, you could reduce it to one line like this if you were a little monster. And didn't want to work with anyone again. But this isn't really reducing the function because you can't drop the braces in the return. You know, it's a different thing. Because if you drop the braces in the return, you'd have like a totally wild function that just doesn't make sense. So that compression, I guess, of it only works if there's like a one-line function with a return. Yeah?
Does JavaScript allow you to use like a comma operator that would allow you to do something like that?
Possibly. The question was, does JavaScript have like a comma operator that would allow you to do something like that? I don't know, actually. I've never tried, to be perfectly honest. Be a great question for Google or ChatGPT. Have you tried it, or are you just curious?
I'm just curious.
Yeah, I'm not too sure. I've never seen it, but you know, so at least that tells me that it wouldn't be common. But whether it's possible, I'm not too sure about. Maybe we can try that later. Yep.
So when you showed us the sum example before,
Yes.
A, comma B. Oh, I think the first one you showed. But then like for these ones, oh yeah. But then after that you've been defining the parameter types. So like A is a number, B is a number.
Yes.
So do you not need to do that if you don't want to?
OK, yeah, so there's a bit to unpack there. So firstly, the first literal couple of slides were in JavaScript just to like warm you into it, and then we moved to TypeScript. However, I still like the question because even in the TypeScript examples, do we really need those? Now, I can tell you the answer. I don't know how much it was covered in the TypeScript lecture, but basically, like TypeScript understands JavaScript, and then it also understands the superset, because you know, like JavaScript's the language that does all the stuff. TypeScript's basically a syntax where you can annotate the code. And all TypeScript really does is look at the annotations of the code to make sure everything looks okay. It strips it out and then passes everything to Node in the end. So JavaScript still runs behind the scenes. Now the question of like, do I need this here, is really all down to configurations. So every single kind of repo or project you have, if it's TypeScript, will have a configuration as to how tolerant it is, basically. You can see it probably here in the TS config. Now, the TS config will tell you a bunch of stuff about what we can and can't do. The way the course is set up is that basically when we run TS node, because remember TS node, like if I start it a different way, there's a command called TSC that you would have seen before. Here it is here. Now, when the TSC command is run, that is the command that goes and strips away, that just basically looks at the annotations and says, is the TypeScript code okay? That's the thing that's making sure you're not adding strings to numbers. The way we configure TSC to run in the course is really, really strict. It basically expects you to go and make sure that everything is typed appropriately. Not quite everything, but like generally a lot of stuff. However, there's another command called tsnode that runs. And what tsnode is tsnode is quite literally, like if you say npm run tsnode blah.ts, it's kind of the equivalent of saying npm run tsc blah.ts and node blah.js, where the output of this command is a blah.js file. So tsnode is quite, just think of it like an abstraction of two underlying functions. So it does the type check, and then if it passes, it runs the code. It's just the way that we configure tsnode in the course, and we've done this kind of forever, so I'm pretty sure it'll be the same, is that when you do tsnode, it skips some of the type checks. The reason for this is because when you're developing, type checking can be an inhibitor in the short term. There's a couple reasons for that. One is that like not all code you write is perfect. Imagine if you weren't allowed to run code unless the linter was okay. You know, I know you haven't probably played around with linting, but there is a point where it's just annoying. Particularly if you're committing code regularly, and particularly if you have pipelines up on, you know, the Git cloud, whatever tool you're using, that's like checking that for you every day or so. Like that kind of keeps you in check. But the other reason is because looking at types is actually quite a complicated process. So if I could, I don't know how obvious it'll be, but like let's take this code example here. If I go into my 4.1 lecture, I will need to npm install. But type checking is not instant. It takes time. So what you'll see in a lot of the package.jsons is that this command here on the TSC is basically like strict mode. And on the TS node, I don't think we have it there actually. Maybe we have it in the project. Let me check if we have it in the project, because I just don't remember. I guess you wouldn't see it yet because it's not, iteration 2 is not out. But often in the project, you'll see something where basically it turns off the type checking with tsnode. So it basically reduces node to something that like tsnode to something that like it can interpret TypeScript, but it ignores it and then it just runs the code. And that is just because it's quicker. Because if you don't have to pay attention to the types, it will be quicker. Let me see if I can demonstrate. I'm just kind of figuring this out as I go, so bear with me. But if I run tsnode on, say, what was the one? It was many string 1, right? I think this will do type checking. I don't know how long that takes. It's probably such a small file that it doesn't really like, it's not really going to matter, which is why I don't know if this example will even work. I did. There you go. Look at that. See that? See the time difference there between like 1.5 seconds and 0.3 seconds? So the difference between that was I added this -t flag to tsnode. And what that basically did was it told tsnode, I don't just want you to like check the TypeScript lightly. I want you to not check it. Literally ignore it. Your whole job is just to strip out types so that Node can understand the underlying JavaScript. And it can do that like that. Whereas type checking is a lot more complicated. And that makes sense because there's a lot to kind of figure out and match up. So in a lot of development environments, people actually, when they're running their TypeScript code, they won't actually have the type checker constantly working. This is a tiny file, and it added a whole second onto things. It's literally a function. You could imagine like a piece of, like a code base with like 100,000 lines of code. The type checking just to spool it up could take like a minute. So imagine every time you change your code, you have to wait a minute for the TypeScript thing to check it all out. But yeah, so I feel like I've forgotten the origins of how we got onto this whole thing. But did you ask a question? I know, sorry, you asked a question. How did it start again?
I was wondering if you needed to put in parameter types.
Parameter types, yes. So that's all background. Apologies for my very thorough background on that. The point is that if you don't include parameter types, then generally the way the course is set up is if you run TS Node is really relaxed, and it'll just be like, I don't really care if you don't have them. I'm not even really looking. However, when you run the TSC command, because the TSC command is configured if you run it standalone to be quite strict, it will complain about it. And the reason that's kind of relevant for you all with iteration 2 onwards is because it essentially means that when you have to start doing TypeScript next week in the project, you kind of don't really need to like do much with it except change your JavaScript file from .js to .ts. And TS Node will just run it, because the TS Node is configured to just be like, whatever, man, you know, like I'll just run whatever. However, later on in the term, when you get to like week 9 and 10, and there are some marks for your TypeScriptness of the code, that's when you'll start running the TSC command explicitly and checking all that. As a general recommendation to groups, I would usually say don't worry too much about the TSC command early on, because it's like, you can always kind of tackle it later. Just like linting, you know, linting, you can always do it later. It's just there's a point where like, it's like cleaning your room, right? Like there's a point where your room is like so messy that you just are like too demotivated to even get to it. It's the same kind of idea. But also if you're cleaning it every single like minute of the day, your life gets kind of like dragged down and you don't really get to do anything fun, I guess. Lots of things in the chat, so I'm just having a quick glance at it to see if there's anything super relevant. Seems fine. Okay, so back to this. Do we need to include these things? We answered that question. Now, this piece of code, we showed that we can change it to function syntax 2, and we can change it to function syntax 3. That all makes sense. Pretty straightforward. First class functions. So the function syntax, I don't think anyone was too mind blown by that. It wasn't very complicated. First class functions, though, are where things start to get a little bit funny. So we know that when we use function syntax 2 or 3, which are the more modern types of syntax, that we can define variables and functions in a really similar format. I like this example here because it shows you that the only difference here is I've replaced the string Hayden with this function here. This is function syntax 3. So it's quite concise. They're quite interchangeable. And I can print them both out, in fact. If I print this one out, it's going to print Hayden to the console. If I print this one out, I'm usually going to get a little like string representation of a function. Usually it prints out like this. If you put these two together, the first one would print out Hayden on the terminal. The next one would print out something like function get name. It prints out some kind of representation of the function, because like you're not really calling it here. I think that's an important point too for people to understand, is that in this code example here, you are printing out the function. If I put a parentheses next to it, I'm printing out the result of calling the function. Because 99% of the times you would print out a function, right? Someone might say, did you print out the function? What you're really meaning by that is, did you print out the result of calling the function? So that's probably how most of your code would look if you were writing a piece of code like this. Whereas this one is kind of printing out, some people might think about it like printing out the pointer to a function or something like that. Same kind of idea. What do these different function syntaxes teach us about functions in JavaScript? It's a good question. That we can treat functions similar to variables, e.g. what we're doing with the console.log. Absolutely. Cool. Therefore, in JavaScript, we can say the language has first-class functions. So yeah, this terminology is quite interesting because first-class functions are a language feature where functions are treated just like any other variable, right? Some of you might have heard phrases before like, you know, what is it? Like here's a good one. Dogs are treated like first-class citizens. It's a phrase you might hear. It means like, you know, they get to eat steak and they get to like, you know, sleep on the bed and all that kind of stuff, right? They like, a lot of people treat them like they do humans. It's a way of kind of articulating that they're just like us too. So that's where the origins of this kind of come from, is first-class functions means that functions, you know, instead of being these like relegated things, we like give them the same privileges as variables. Most notably, though, the reason this topic matters is not because we're talking about definitions, but because a language that has first-class functions allows you to quite easily pass in functions into another function just like a variable. That's a little bit of a funny idea, because you're kind of like, you're already used to the idea, this is the way to think about it, you're already used to the idea that functions can produce different output based on variables that you pass into it. So I have a function here called say hi. And inside that function, it takes in a string called name. And it will return a different result purely based on what I give it. If I give it a name of Hayden or Yuchao or anything like that, it'll give me a different result. We all kind of get that. We know we can call that function that way. However, a first-class function literally employs the same principle. It's just that instead of a function being different based on the variable you pass into it, it's just different based on the function you pass into it. You're just passing functions into functions. So let's really try and stare. This is probably the first code example you have to really look at for a few seconds. Is like, don't worry about this top line, that's just TypeScript. But I've basically got two functions here. One of them's called brackets, and the other one's called full stop. The brackets function, when I give it, this is not first-class functions, these are just helper functions. When I give it a string, it literally just returns me the string with brackets around it. It just wraps brackets around my string. The second piece of code just returns my string with a full stop at the end. You know? That's all it does. This is kind of where things get a little funny. And this is where you probably need to stare at it the most. I've now got a function called say hi that takes in not only a name as a variable, we get that. That's what this code was. But it also takes in a function. So my function takes in a function as an input. And what it does now is it says it returns hello, comma, and then it returns passing name, one of the inputs, into format, the other input. And it returns something. And what this means is that you already know that you can get a different output by passing in Yuchao instead of Hayden into a function, right? We know we can change out a string or a number. But the other part now is we can just change out a function. So instead of changing the Hayden to Yuchao, we can just change the brackets to full stop. We can change the function that we're giving to our function in order for it to have a different kind of result. So if I pass in brackets, then when format is called on this line, it's basically calling the brackets function, because I passed in brackets as format there, and it called brackets on my string. Whereas if I call the function a second time and I pass in full stop, the format name is full stop, the function, and then it calls full stop here. Now I'll just run that for completeness over here, npm run ts node fcf format atomic. Whoopsie. Oh, it still figured it out. I didn't realize you don't need the .ts. We've never done that before. Oh, it did. It auto-completed? No, it didn't. Magic. We're all learning every day. So yeah, you can see in that case it printed out hello Hayden with the brackets around it, then the double dashes, and then hello Hayden with a full stop before the exclamation mark. Pretty cool. Okay, so simple. You already know functions can take in different things and it gets different outputs. We're just doing it with other functions now. Any questions about that? Just before we keep moving. It's probably the first sticky point for some people. Cool. Now this is where the new function syntax starts to get a little bit fun. I'm going to do this like more directly rather than showing you a slide. If I have a look at this one here, what do we know about the third type, well, the different function syntaxes? I've got three functions here. I'm going to go convert them from function syntax 1 to syntax 2, like that, right? Sorry, like that. So I just say const variable name equals a function. So now everything's just const something equals something, const something equals something. If I go to function syntax 3, I drop the function and add the little equal arrow to the end of the code. Okay, sure. That's not really strictly easy to read. I find that pretty easy to read, but I work with this every day and have for a long time, and you would get pretty comfortable with it too. But it's kind of the same, essentially. Where things get interesting is, again, dropping the braces. Because these are one-line functions, I can drop the braces and do this. Now initially, this might be harder to read because you're not used to it. But it's actually a very concise way to read code in certain languages like JavaScript, because we're simply saying now brackets, and I can tell it's a function because of the parentheses and the little arrowy things. I see brackets as a function that takes in a string and returns that. That's all it does. This one's something that does that. I could make another function called uppercase. This would be the dumbest function because there's already one of these in JavaScript, where all it does is like makes it uppercase. I could make another one called lowercase, where it simply does that to lowercase. You know, But I'm making these functions, and they're nice little one-line functions, and they're very straightforward and quick to read in a line. Now the interesting one is, would I make this one a one-line function? Now the funny thing about these kind of one-line functions is there's a magical point which isn't well defined, which is kind of up to you to figure out in general, where it's too much to read, you know? Like these lines aren't too bad to read. They kind of explain themselves pretty naturally. Okay, brackets takes in a string, returns a string with brackets. Pretty quick. This one here is kind of like, I think this one's okay, but I think much more complicated than it. It's a little bit hard. Say hi, okay, it's a function takes in a name and a format, but then you're like, what the hell's a format? It's this thing up here. Okay, so that's a function that takes in a string. And you're like, hello, returns format name. Format was that, name is that. You know, like your eyes and your brain have to dart around it quite a bit to like unpack what's going on there. So I'd say that's kind of starting to get borderline. It's like at some point, you're not really simplifying your code a great amount, you know? And maybe that would probably stay like that. I would probably leave that code just like that. I don't really think I'm doing anyone any favors by simplifying it down. It's really tempting to when you learn a new thing, right? Like in general. You see this all the time with programmers, is that when they start programming, their code's really verbose, and then they go through a period where their code is like super concise to the point where no one can read it because they feel like they're really, you know, they're like, I'm a little bit smarter now and I can make like really clean, tight code. And then they kind of realize that usually it's not so much, I think, when programmers see code that other people have written. Like, because in uni and stuff, you really don't often have to write that much code that other people see. You do in this course, obviously. I think usually one of the big things that really develops programmers and their natural sense of like where the balance is between conciseness and clarity is when the first time you ever look at code you wrote that you have to work with again that you wrote like a year ago. Because a lot of code you write, like if you went back to the project, like you're doing this project this term, right? If you went back to this in a year, like let's say you're a tutor, right? This actually happened with a tutor, was like, I was like, okay, the model solution we're gonna have, go get your project from a year ago that you did as a student, now that you're a tutor, and go and change it to have the new stuff in the spec, and we'll use that as the model solution, right? Those experiences typically are when people really develop their understanding of where the line is. Because when you look at your own code and you're like, oh my God, I don't really know what this does now. Whether you didn't comment it or you oversimplified it, etc. Just looking at the chat. So a few questions around this top bit here. So type is a particular TypeScript thing. So just for clarity too, when I said before that TypeScript, the TS node, when you tell it to ignore the types, it comes in and strips it away. What it literally would do, this just kind of completes the previous topic, it would come here and be like, well, that's TypeScript, gone. And then it would look at this, and this, and it would be like, that's all TypeScript, gone. It just strips it out, and now all of that code Node can interpret natively. So it just shoves that into Node. That's what TypeScript does on the turbo mode where it just skips everything. But this up here is TypeScript. So in TypeScript, you can kind of make a variable, except it's not really a variable because it doesn't have a value. It is just a definition. People have said it's like a type def, which it is. It's quite literally a type def. And the point of that is that you could imagine, what is the type of format? It's a funny thing, right? Like if you think about types of numbers or strings or booleans, it's not hard. It's a number or a string. But format's a darn function. Gosh, what's a function? What functions are being passed in? They are functions that take in one string, and they'll typically return a string, right, at the end here. So the type of that function is literally a function that takes in a string and returns a string. A little bit heady. I don't need to have this line up here. I could just do this. But you know what? I think that's a cruel thing to do, because that's confusing, even for me. I see that stuff all the time, and even I look at that and I go, oh, I don't really want to understand what that function's doing. It's a bit too complicated. It's like it's a name that's a string, and then it's a format that's, what in the hell is that, you know? So what we do is we might go and take that and separate it out, just so someone can be like, yep, or you could call this string to string, might be a better name for it, you know? Okay, function takes in a string, returns a string. You can call it anything you want. But this is just like a type def in TypeScript. Someone says, can you go through what every line from line 8 on and what they do? I kind of feel like I have. Not to be annoying. You could ask me, I'm always conscious that I don't want to waste too many people's times. But if you ask me a more specific question, because I feel like I have, but there's probably aspects of it I missed. So for example, one thing I might have missed here is like, this plus here is just me concatenating strings together. So for instance, I could write this a few different ways. I could write it by not using the new lines. The only reason I don't do that is just because the line gets really long. But that's okay. That might even be an easier way to do it. The other way I could do it is I could simply create a result string that is an empty string, and then I could just say result plus equals and keep like kind of adding to the string if I want to. So I could do things like this where I'm like, yep, result is that, and then I'm going to add on that to it, and then I'm also going to add on that to it as well. Could also write it like that. Someone said, why do we need string to string? Well, like so if you don't have that, then TypeScript doesn't know what type it is. And what I mean by that is like, let's imagine if this was just JavaScript and there was no type there. This is kind of the problem with JavaScript and Python and these languages that aren't typed by default, is that if I just take this code for a second and I simplify it down, let's just make it more classic JavaScript-y, right? One of the problems with code like this, and maybe I'll literally just run that. I'll call it like egg.js, right? So this isn't TypeScript. And this should work if I just run it like node egg.js. It just works fine. But one of the problems is that if I make myself another function here that takes in, say, you know, a number, num1 and num2, and then it simply like returns me num1 plus num2, right? It's basically a sum function. And then I call this with a sum function. What's going to happen? It ran. So I don't know if Yuchao would have talked about this at some point in a previous lecture, but one of the ironies of bugs in programs is that the best thing that can happen for your program if it's broken is that it doesn't run, right? Now it's a little unintuitive because it's like, you know, let's say you have a car, right? You'd think, oh, well, if I have a car and something's wrong with it, I'd rather it still drives me to where I want to go, even if it's a bit, you know, broken. That's better than like turning the car on at home and it won't start, because then I can't even go anywhere, you know? I haven't even gotten half of what I want from it. It's just totally broken. With software, it's not quite like that because, you know, I mean, it is still like that with a car, right? Like if your car's broken, like if a bloody wheel nut's loose or something, you'd rather it not turn on, right? So like, it's not that it's different with a car, it's more just like intuitively we think the further it goes, the better. But like if you had a car that like part of your wheel was loose and it was going to fall off on the highway, you'd rather the car just not start, right? You'd rather it do some static analysis of itself and be like, no, we're not going to go today, rather than being like, let's just go and see what happens. And then on the highway, you know, you crash off a bridge and die or something. So it's like, code's the same as that kind of idea there, which is that this code ran fine, but it printed out undefined there, which isn't very good. What happens if I just had num1 plus 1, something that I expect to take in a number? Now it's even worse because it isn't obviously broken. It still kind of worked, you know. This one, I mean, this also kind of worked, but it's so clearly not happening. And the reason this isn't good is because it is not, it's a different type of function. What's the type of this function? It's a function that takes in a variable called num1 that is a number, and it returns a number. That's what it's meant to be. So when we add types into our code like this, we're essentially just giving TypeScript ammo to protect against us. We're basically adding sensors to our code so that when we try and run it, it can check a bunch of things. That'd be how to think about that to the question about you know, what exactly is string to string in that context. Okay, this is a good question. Does the type refer to functions with parameter names string specifically? I don't believe so, no. So what they're asking there is, like, let's try it out, because I'm pretty sure it doesn't matter. Like if I just called this hippo or something, that should still work, I think. I have to get rid of some of this that I wrote, but let's try that out. What was that one? npm run ts node format atomic.ts. Still works, yeah. This doesn't really matter. So it's like that in C, right? With prototypes. Out in C, you can kind of just like name your prototype anything.
Yeah, I was just going to say, it's like function pointer type defs in C.
Yeah. Yeah, exactly.
Prototypes in C.
Yeah, 100%. Yeah, exactly. I always wonder, I don't think variables can start with like, yeah, they can't start with numbers. I don't think they can be emojis either. No. Can you have emojis in a variable? I don't think so. No. One day. There'll always be some update. I remember the day it was like Google Docs. One day I was like, oh, I didn't realize you could just name a Google Doc like emojis. Like I had this one Google Doc once where I was planning a trip with a friend and I just named the doc the plane emoji, which I thought was really cool at the time. But then we couldn't figure out how to find the doc because we didn't know what to search, because you can't like search plane and it comes up. Okay, another piece of code for something more complicated. We'll take a break soon, but bear with me for just a little bit. Yep, let's get through this, then we'll take a break. So, more complicated example, FCF format loop. Okay, so similar. String to string format type, brackets and lowercase, except what's happening here is a bit more involved. We have a const names equals this, which is an array of 3 persons' names, 1531 people who help out a lot. Then we have a function called format names. And what format names does is it takes in a list, which we expect to be a string array specifically, and it takes in a format, which is a formatter, which is just the thing that does string to string. So a very similar idea. It's just instead of taking in a name, we're taking in a list of strings. Now what we do here is in our function, we create a new list, totally empty list. We then go and loop through the list we were kind of given in, and for each one, we push that item to the list. However, we don't just push it to the list. We push it to the list after we format it in some way, right? So it's kind of like we loop through the old list, and we modify it, and then we dump that in the new list. So it's like a transformation function, essentially. And then we return that new list. And then now what I can do is I can say, you know what? My new names, I'm going to format the names of my names list with the brackets formatter. Then I'm going to go format it with the lowercase formatter. And we get it, we get a good result. FCF format loop. There you go. So we had this Hayden Juliana Tam list, and now we've gotten a list that has brackets around it, and we've gotten a list that is lowercased. Or, yeah, lowercased in this one. Yeah, so that's pretty cool. That's useful there. Again, naturally, we can go and simplify this down to a, more concise element. And you probably would normally do that, because again, they're just such short lines. There's the example there. The one thing that we haven't talked about, though, is anonymous functions. Anonymous functions are an aspect of first-class functions. What you've seen us so far do is utilize the first-class function capability of JavaScript, but every function that we pass into another function, it's had a name associated with it, right? Like each function's had a name. Whereas here, what we can do instead is we don't necessarily need to use the name. I can kind of just copy and paste this as it is, and I can just kind of paste it right there. Like if you think about it intuitively, lowercase is literally just saying like the name lowercase is a thing, and then we pass lowercase into the function. So rather than like say lowercase is a thing, why don't I just paste it here? Like I can do that. And you kind of know this again intuitively, because you know that if I say something like a equals 1, b equals 2, c equals a plus b, you're like, yeah, but I could just say const c equals 1 plus 2, Like I don't really need to like break that out. You don't have to. And this exact same thing applies to functions. And this is the cool thing about first-class functions, again, is that you can literally employ everything you know about variables into functions in that sense. So I take this, and I go and paste it down in here, and now that works. So I run it again, should work fine. Now the interesting questions are like, should you do that? And when should you do that ever? Well, the golden rule with anonymous functions is you pretty much only ever do it when you only use the function once, right? Anytime you use the function more than once, that's crazy to do, because if I'm going to use it again later on, I'm just going to end up copying and pasting code, which breaks like one of the earliest rules of code, which is try not to repeat yourself. So we don't want to do that if it's going to happen more than once. But it's great when it happens exactly once. The other time it's a little tricky is when it makes the code harder to read. We've kind of talked about that one already. Something like this is probably a little bit borderline, I think. Like at some point, it's just easier for someone to write like a line above it called to lowercase and then to just be like lowercase there, I don't like the fact that this variable's colored and this one's not. Probably screwed something up there. Let's find out. Nope, it's just the editor. That's funny. So like I'd probably break it up like that. Sometimes that's easier, just to put it on the line above. Because if you think about it, one of the better things about anonymous functions is that you basically can contain all the information down to one spot. You don't really need to like break it up into many lines. Because remember, your eyes are always trying to read code. So if it sees a name, it's got to interpret the name another way. Now editors help this out a lot nowadays too. Not this one, but if you put your mouse over it, it'll typically like take you to the thing, or like VS Code will be like, that's the definition of it too. So editors can help bridge this gap quite a bit. But that's what an anonymous function is in the world of first-class functions. So in summary, first-class functions are predominantly used in terms of letting functions take in other functions as arguments. That's why we care about it. And this allows us to make more concise and clear code. Let's take a short break before we get into the rest of this stuff. So take 5 minutes, then we'll keep going. Hi everyone. Sorry to interrupt your, no doubt, very meaningful conversations. Let's get you back in the headspace of learning. Come on. Yay. Everyone just listening to their conversation. All good. Okay. Let's go. So, map reduce filter. One thing that I up to this point in the lecture, I think what's hard is that all this stuff kind of just feels like randomness in a bit. You know, like here's some random stuff we can do if we really want to. But I like talking about map reduce and filter because they're kind of where a lot of it ties together, and you're like, oh, I see where this is actually really, really handy. Basically, this is true for Python as well. In a language like JavaScript, there's three really fundamental functions, and these aren't JavaScript specific again. They're more like conceptual ideas called map reduce and filter, which are basically functions that act on arrays. So if you have an array, you can map reduce or filter that array. So it's all about arrays. A map is about modifying an array. It's about taking an array and transforming it. A filter is about pulling a subset of items out of the array. And a reduce is about summarizing an array into something small. So map, firstly, takes an array of size n and it produces an array of size n, but the objects in the new array have been modified in some way. The really key point here, though, is that it's an array of n and ends up as an array of n. The size doesn't change. So if you have a 10-item array and you map it, it becomes another 10-item array. Cool. So that's it. Same size array, modified elements. This is a good example of it. So we have here on the left, we have tutors, Simon, Teresa, Kai, Michelle, 4 tutors. And then we pass it through this map function here. Now, hopefully this map function is a little bit easier to read than maybe it was before. Let me just pull it up like this. Because let's think about what's actually happening here for a second. And I might actually pull this out like this. I might call this fn, and I'll say that. So what's happening is that we're defining fn, my function, as a function that takes in a string, and it simply returns my string uppercased with 3 exclamation marks. It's a pretty simple function, you know, week 1 kind of function. But what I do is I pass my function into this map call. Tutors is an array of 4 strings, and I say tutors.map. And what do we say a map function does? It takes an array of 4 elements, and it gives me a new array of 4 elements, except they've been changed. How do we know how to change them? We call the fn function on all 4 of them, one at a time as we go through it. In fact, the reason this example's first is because we did this about 20 minutes ago, right here. This is the exact thing we did. We basically wrote ourselves a map function manually here, you know. We did it. We were like, okay, we're going to create a new list, then we're going to go through the old list, and then we're going to modify each element in the old list and take it to the new list, and then we created a new list. And if you go back through our code, that's what we did. We took an original list and we created a new list. The original list had 3 items in it. Our new list had 3 items in it. So what this is literally a syntax to simplify that down. Because what you see in a lot of programming, particularly high-level programming, and high level doesn't mean complicated, it means like a high level language like not C. You're manipulating arrays all the time. You're doing so much stuff with data constantly. So why not have a helpful function that you can do that with, where I can then say npm run ts node map old. You'll notice in this code too, I don't have any types. Well, I do have types, but if I get rid of the types again, ts node will run it fine. It doesn't really care about that because of how we've configured it. Now, because this fn function is only used once, I can make it an anonymous function. An anonymous function is a function without a name that I pass straight in. And whilst this might look unfamiliar to you, this is actually where some of the things around anonymous functions, first-class functions, the function syntax 3 all come together, because this is a pretty standard piece of code. And in fact, we can make it even shorter, can't we? Because if I take this up here, it's a 1-line function, so we end up with that. And let's say I'm just going to call it yell. Takes in a string and it yells it, uppercase with exclamation marks. I can take that and dump it here. And this is actually a good example of a line that, whilst might be a little bit confronting at the moment, is a pretty reasonable piece of code for a JavaScript developer to write. It's a very straightforward 1-line function. I take loud tutors. Sorry, my loud tutors are my original tutors. I'm going to map it. Oh, that means I'm going to modify each element by I get each element and then I do that to it. Really concise, all handled for us. So that's the map function. Creates really simple lines of code like that. That's basically what these ones are. Played around with some syntax. Any questions about map? Yeah. It's a great question. It never modifies the original array. So it's always creating new things. It's a good question. Cool. The next one's filter. Filters, I'd say, also commonly used. Maps are used all the time. Like I'd be using a map function every, like, I don't know, 2 hours of JavaScript I write. Like, I don't know why that's a random measure, but it's very common. Filters also very common. I'd probably say I end up using filters less than maps, but it kind of depends on what you're up to. A filter is kind of like a map in reverse, right? Like if you think about it, a map is about keeping the list size the same, but transforming the elements. A filter is about not touching the elements, keeping the elements the same, but it's changing the list size. And the list size is either going to be the same size, or it's going to be 0, or somewhere in between. Because you're essentially just filtering things out, right? It's like if I give you if I pour marbles on the ground and say, like, I want the blue ones, you literally just go through each marble, and if it's not blue, you like knock it out. It's the same principle. It's very, very conceptually straightforward. And let me just open it up in the editor so it's a bit easier to see. But here's a piece of code. This is a map function, and I've started this one really simple too. We have students. It's an array of objects where each object has a name of the student and a mark for the student. And what we do is we simply say students dot, what is this map? Why is that filter? Oh no. Someone's messed something up. I don't know. That should just say filter. I think that's just a typo. I don't know why that's there. That's weird. So we say students.filter, and we quite literally go give it a function. And all that function does is it takes the student.mark and it's bigger or equal to 50. Now, I want to not start there. I want to start with like something broken up because I think it's easier to read. And if I, again, break this up into older function syntax, you can start to see it like this. There you go. That might be a bit more concrete for you. I have a pass function. Make it really concrete. I have a function called pass. It takes in a student. That's an object. You know about that through your project. And the object has a property called mark, and I simply check, is the mark greater or equal to 50? That's all the function does. It's literally just checking if an object's property is greater than 50. I can reduce it down to one line like this, and once it's down to one line, I can pass it in. Because what the filter function is going to do is it's going to go through each element in the list one by one. It goes through this element, it calls the function on it. It goes through this element, it calls the function on it. All functions that you pass into filter return true or false. That's what they do. Right? The map's a little bit different. The map returns you a new item, but a filter returns true or false. So this function here is always going to have a truthy value at the end. Again, it's either going to return true or false. Naturally, this will return true or false. If I wanted to really break it up for you, you could write it like super verbosely. I could grab this, I could call it pass, and then I could say function pass student this. If student mark is greater or equal to 50, return true, else return false, right? Like that'd be me like unnecessarily expanding this out, because every function needs to return true or false. Just because we don't have true or false there doesn't mean like that's not important. It's just that, you know, naturally this returns true or false. So this kind of function, you've all probably written a function like that at some point. I know I have. It's kind of redundant because the condition itself is truthy or falsy. So if you ever have a if something return true or else false, you can. That's where you just get into, you know, the return that. It's basically just taking the thing out of the if statement. I've got to keep messing this code up. Cool. So take that, dump it in. That's a filter. Really easy. I like it because, like, you know, it's once you kind of get the gist of it, they're really straightforward. And what's nice about them is once you do understand the concept, they actually make it easier to write code because, you know, it's just very concise. So for instance, let's say I didn't want that, and someone said to me, I need a new list that only gives me short names. Well, I'd be like, well, okay, students, I got to filter it. What's each element in the list? It's a student object. Okay, cool. And then for each student object, I want to get the name, and then check if the length is less than 5, you know? And bam, I just wrote a function that like captures all that for me. Really, really, really neatly. The other one is reduce. Reduce is a funny one. I always kind of talk about it as a funny one because I just don't think it's that useful. Like, we say map, reduce, filter, and they're kind of three different functions. You know, where reduce is different is that its job is to take a list and turn it into one thing, right? Like you think about reduction is a great word. If you're ever cooking, someone's like reduce the sauce. You know, it just means like boil it off and get it down. But it's just not that like common, like day to day. So for instance, this code on the left here, and I've kind of got this code example to make the point. This code on the left, it has a bunch of students and they have a bunch of marks, right? And yeah, each one, so name mark similar to the previous example. If I want to say sum up the marks, right? That'll be pretty easy. I say, you know, I let single be 0, like my starting point. I loop through all the students. I add their mark to the single variable, classic like loop through and sum, and then I console log that. We can also do this with the reduce function a similar way, where what we do is we get our students, and then we call students.reduce, and we give it a sum function, and every reduce function needs like a starting value. It's just kind of how it's structured. The way the reduce works is really interesting. I think it's worth me trying to visualize it for you. So how it would work is, let's imagine you have 4 numbers. I'm going to write them out here. They're going to be like numbers 1, whoop, damn dots, 4, stop it, 5, 8, and 9. The way the reduce works is you give it an initial number of 0, right? It needs an initial number. What it does is, for the sum one at least, it basically goes and says, hey, I'm going to go get the 0, my current running total, and the next number, and I'm going to reduce those two together. Now the output of that is naturally going to be 1, right? And then what we do is we say, well, the next thing we're going to do is we're going to go and, kind of need the brush for this, we're going to go and take the 1, which is the new running total, and we're going to get the next number. And what happens when we try and reduce those two together is we get 5. Okay, well, now I'm going to go and get the next one, which is the 5. I'm picking awful colors, I'm sorry. And 5, and when we reduce that together, we get 10. And then we take 10 and 8, like this. And what are we going to get? Surprise, 16. I'm kidding. And then we take the next one, and we get 27. That's how reduce works. It kind of, it doesn't just like sum it all up. Structurally, it starts with a number, and then it grabs that number, and then it grabs the next element and tries to reduce that, and then it grabs the next element and tries to reduce that. So it's kind of like this hungry hippo just munching along through the list. The reason I point that out is because the code makes more sense now in a way, because what the function that you give it does is it quite literally takes like the running total. Prev here means like your starting value or the running total that you keep reducing it into, and then current's like the next item, right? So this function, basically this function is applying like these circles I've been drawing. So it gets called each time, and it kind of like gobbles up the next thing, where current's the next thing, and we're trying to shove it into prev. Prev's my number, and the number we keep shoving into prev is like current.mark. And that's the sum function, and that's how we use it. Now that makes sense once you understand it. The problem with it is just the number of reductions that people do, I think, day to day with coding, on average, is not that high. And also, because it's a little bit more conceptually difficult to understand, and for simple examples, the code is not trivial, it can kind of turn people off using it, because it's just not that common. Does someone else want to tell me a common function that you can think of that might use reduce, like might be a reduction in some way? Yep. Adding a list of numbers. Yep. So summing up numbers. Absolutely. What else? I can only think of like 2 others, to be clear. It's not like some big open list, but. So there's a JavaScript function called math.max. Now, math.max takes in a whole bunch of numbers. You can give it as many numbers as you want. What does it do? What does it return? One thing, right? So finding a max or minimum, I mean, this is the problem, is like, there's a function for this, so you would never use a reduce to find a max or minimum, you know? You would just pass in your list to it, because it can just handle it for you. But I think what's important about reduce for me is not that you go away and use it every day. It's like you understand the concept of a reduction, which is taking a list of things and making it atomic to one thing. Because that's what math.max and math.min are. They take any number of items and they always return you 1. So they are a form of reduction in that sense. Was there a question? Did my brain? No. Okay, all good. I don't think we need to unpack this too much. We've just kind of shown how we can use anonymous functions. But combining them together, I think, is really where the magic of it begins. And I don't normally write this out. I normally explain it. But I just want to kind of show you. So let's say someone said to me, here's a bunch of marks. The marks are out of 60 for the final exam. I want you to tell me what the average pass mark is. You know, so we take all the students who've passed the course. What's the average mark they got out of 100? Okay, well, what's the first thing I do? I'll say, I have to normalize the marks. To do that, I'm going to map it. I'm going to take each mark, and I'm going to, divide it by 60 times it by 100? Something like that? You know? Because they're out of 60, so I need to make them out of 100. Okay, now what I want is passing marks. Well, I go get the normalized marks, and I'm going to filter it where each mark, I only want the ones where mark is greater or equal to 50. Okay, cool. And then what I want is I want to sum them up somehow. So I say like sum of marks equals passing marks dot reduce. For sum with, like when you want to sum numbers, like I only ever use reduce to sum numbers, and I always forget how to write it, and then I usually like either think about it for a second or Google it. But the summary of it is it always kind of looks like this, because like it's basically that you're starting at 0, and what's happening is you have a function that's just moving through each number and like adding it together. So there's my sum of my marks, and then I could say const average mark is just sum of marks divided by passing marks dot length, console log average mark. Okay, and then we'll try that out. Node npm run map reduce filter. Sorry, camera looks a little wobbly. Map filter reduce, sorry. TS node. Node npm, okay, that made next to no sense. There you go, 68.5. I think that's right. But I think this is kind of the example that's meant to tie it all together, because it's I wouldn't say that's the prettiest code I've ever seen, but it's very straightforward, you know? Like a lot of this stuff's about data manipulation. And if you think about it, you know, this is such a good example too of where these high-level languages as opposed to low-level languages have strengths. Because if I said to you in C, you know, there's some numbers in a file, find me the average passing mark, you know, it's a lot of messing around that you would have to do, you know, like firstly, if you're reading in numbers from a file, I know we're not here, but like you would have to be like, well, I got to malloc something because I can't do a static array size because like the array size is not known at compile time. So you got to malloc it, then you got to think about freeing it. Then you got to read it in. Then you got to make another list and loop through it and modify it or modify it in place. And then you got to, you know, like it. This is very straightforward, and it's why we use these slower but easier to use languages like JavaScript in general. Now, last part of today, which I think is a bit of the, I think this one's actually conceptually the worst, because everything else we've talked about is pretty simple. Some syntax, first-class functions, wow, let's use them a bunch. This does use the concept of first-class functions. It has nothing to do with map, reduce, or filter. So think of it like just before we did map, reduce, or filter, we could have also talked about this. Higher order functions, sometimes you see them referred to as HOF, are essentially functions that return functions. Oh, okay. So when we learned about first-class functions, we were learning about how functions can take in other functions. But they were still kind of giving us a value back, right? And pretty much every value, every function you've probably ever written in your degree so far probably returns a value, right? This is about functions returning functions. Now, this is not that example, so don't try and look for that there. But it's a really simple example where we say, you know what? I want to have a different message about like passing, credit, distinction, high distinction that I can call. You know, so a student gets a pass, I can call this function and it'll print out, you know, congrats on the pass. If they get a high distinction, I can call a different function. Each of those functions takes in a name. Makes sense. So if I want to say congratulations to Hayden for his credit, I say congrat mark credit Hayden. It prints it out for me. I know you know that the code's going to work, but again, for completeness, there it is. Congratulations, Hayden, on your credit. However, we could, and you might be thinking about this, as a good programmer, you know that redundancy is usually a bad thing in code. So if you see repeated things, you should try and pull it out. And if you see like all this like congratulations thingy, you'd be like, well, maybe I can separate that out so that instead of, you know, all this repetition here, I've now got this. So I created myself a wrapper function where each of my functions now, instead of printing out, maybe I'll put these on the same line, it might make it clearer, right? Instead of like congratulations and all that kind of being the same, I'm like, well, congratulations on your is repeated every time. So I go make myself a helper function. This is still not higher order functions. This is just functions calling other functions inside of them, right? It's pretty standard. So when I call congrat mark credit, it calls congrat wrapper and I give it credit and I pass through the name and I get a dynamic string. Just reducing repetition in my code. Nothing too new. This is now just moving to a different function syntax. So if I just spread that out, all I've done here is changed it to the function syntax 3. Nothing too interesting. But this is where things get weird. So now what I've done is, instead of kind of just saying I've got this congrat mark pass and congrat mark credit and calling all of this, I am now creating a function called genCongratMark. And this might be the first function you've seen that returns a function. That's its job. A little bit hard to understand, but each of these lines here results in a function. And I'll show you what I mean. If I try and print out these three things, right? I'll just console log them. Let's see what I get on the terminal. I get function, 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 right? Obviously, the interpreter, like, I'm not calling the function, I'm just trying to print the function, and it's like, I don't know, man, it's just a function, you know? So in this case here, I am generating functions from this function up here. If I was to make a simpler example, I'm just reflecting on previous times I've talked about this. I want to start with an even simpler example. Let's say I create a function called genCongrats, and all it's going to do is it's going to create a function called congrats, where what it will do is it will just console log congrats like that, and it will return congrats. And then I say, like, you know, my function equals genCongrats. And then I could call that function. This is a very, very bare bones example of how a function can create another function. And in fact, to simplify that more, just to make it clear, that would be it. So I create a function called genCongrats. It literally just defines one inside of it, and then it just returns that, it just returns that function back. Right, so there's like a little world happening in here where it does some stuff and it just gives me a function back. And that piece of code will just print out, what's this problem? Get. It'll just print out that's kind of silly. It should probably like return congrats. Sorry about that. The string, too many congrats floating around. I'll just say yay, less congrats. Okay, so a function returns another function. Cool. So when we then have a look at this example, we can kind of follow a similar thread and try and unpack that a little bit more, because this genCongratMark function, what it does is it creates a function called ret and just returns it. So that makes sense how these three become functions themselves, because I call a function that gives me back a function, which I made here. And each time it's like a function factory. It's just generating them. Now, the function that it returns is going to be a function that takes in a name and returns this string. OK, that makes sense. That explains how I can call it like I do here, where I say congratMark credit and then Hayden. I pass that in. And in fact, I could make this even easier for you to understand if I dropped this mark string here. Let's just replace that with mark for now. Keep it really simple. I feel like you should be at a stage where, got to get rid of that. Right, this kind of makes sense. I call genCongratMark. It creates a function that takes in a name. It returns that. And then when I call it later with my name, it does what I think it's going to do, and it prints out the string. However, what this means is every time right now that I call this generate function, it's going to give me the same function back. There's no dynamism to it. So if I'm like, actually, like, I want my function factory to be able to produce something that's not the same thing every single time. So what I do is I give my function factory a variable itself called markString. And I can put it here. And then what happens is when I call this now, I simply give it the string I want it to use, like credit. And then I can call it a whole bunch of other times, like this. And I could do this with, pass and credit and distinction. And I'm now able to kind of generate functions on the fly. Now, I won't lie, this is a really simplified example, and I think the examples that really make this clear are like much more complicated ones where I have to like explain a bunch more code. So like don't take this as like a use case as much as it's more just like a playground. Where you'll see this kind of thing often, you'll see sometimes this treated as like, they might call it a decorator pattern. If you go do 2511 and you kind of hear about decorator pattern, I wouldn't call it exactly the same thing, but the decorator pattern's a notion in programming where you basically take a function and you kind of wrap something around it. That's kind of what's happening here in a sense. Like we kind of have our function here. This is our function that prints the string, and we're just kind of like painting it, you know. Other times you'll hear about things like factory patterns and stuff, but it's all kind of the same idea. It's just a function that returns a function. That's all these things are at the core of it. And they are quite useful too. But we don't go too in depth in the course. We just kind of want to touch on it so you know what it is. Yeah. Okay, so I wanted to show you this too. Let's say we use a new function syntax. I'm getting sick of saying that phrase. Sure, sounds fine. It's a little bit harder to understand. If you work with enough JavaScript, that is not too bad to look at, but I think it's a bit harder to understand. The lack of the word function there makes it feel really messy. Here's an example of where you can make your life pretty miserable by trying to make your code too clean. Let's say I now take this return here and I put it here. Okay, firstly, that's a little weird, right? Level of understanding dropping. Too many returns and functions and nestings. And then someone says, oh my God, I just realized that these are all one-line functions. I'm going to go and drop my braces and return. Okay, and then it's like, oh my God, this is a one-line function now. I'm going to go drop my braces and return. Okay, well, now you have this ugly piece of crap here. And I can tell you firsthand, that is never easy to understand in most scenarios, right? You really have to see a lot of code for that to be, you're like, look at that, you're like, oh, obviously it's a function that's generating another function. And the first function is parameterized on mark string so that it can dynamically generate a second function that's when it's returned and it's called, it can get passed in another name, then it gets something, or like, as a general rule, if I ever see two equal lines in a, like if I ever see two equal arrows in a line, I'm like, no, I've gone too far, you know? And just like a typical casual programmer is going to stare at that for a little bit too long. So it's a good example of restraint. I don't really know where you draw the line on something like this, but you definitely, I definitely don't think this would be a candidate for like one line reductions. Yeah, like it just gets weird. You know, like you could talk about a whole bunch of other crazy examples, like, you know, it's a function that takes in an A that returns a function that takes in a B that returns A plus B. It's like, what the hell is that, right? Well, that's like, you could say sum1 is a function sum that takes in 1, and then you would say console.log sum1 with 2. Following that, right? Probably not, because it's stupid. But, you know, if I wrote this a different way, and I said function sum takes in an A, and then we create a new function again called, you know, whatever, my new function that takes in B, and then this one is simply just going to return A plus B. I'm not saying this is suddenly better, but you can reason with it a bit quicker, you know? It's a little bit more obvious that like, okay, I'm creating a function that takes in a value and simply attaches it to the previous one. Even then, the example's so stupid it's not even going to make any sense. Point is, don't go crazy just because you learn something new. That's kind of the main thing. I'm just going to double check there's not more kind of comments here. Any questions too from the crowd? Someone says, C is superior because it lets you use emojis as variables. I did not know it did that. There you go. That's pretty cool. I love emojis in Unicode. Like I know I talk about it all the time. I just love how I can like put a unicorn in the terminal and do that. I love how I can create a file called unicorn where all it does is prints out a unicorn, and I can just call node unicorn. Yeah, it is. Sorry. Yeah, it's fun. How is that not fun? Yeah, I think that's kind of it. I'll just double check no one saw I was reading it and asked a question. Any questions before we wrap up? Bit of a dry lecture in a way, but tried to make that as fun as we can. I guess just my last comment. I hope that now what this does, because this is kind of the point of it, is that it does make it easier when you go back and you look at code where you see things like this with jest. You should start to actually understand what you're looking at now. You're looking at, this is a function, and what it does is it takes in a string to describe it, and you give it a function that it can call later, And then what does it call later? It calls this test thing, which is another thing which it calls later. And then if you think about Express, you have app.get request response like this. What is this exactly? Well, it's a function. App is my server, and .get is a function. And what I'm basically saying is, hey, well, actually, it takes in a route too. Hello. You can kind of unpack that and say, well, what's actually going on there is that I'm saying to it, hey, server, I want you to create a get method route where when someone calls /hello, I want you to call a function. And that function is purely something that takes in a request and a response, and it does some stuff, So that's, I think, probably the main practical takeaway of this, and we probably wouldn't talk about this in this much depth if you didn't use libraries like Jest and Express, but this will help you reason with what's actually going on here now, because you could rewrite a lot of this just like this. It would work fine if you wrote code like that. In fact, you could do it with Jest too, just like that. It's exactly the same thing. It's just code taken in functions taking in other functions. Anyway, thank you all. Have a great day. I can't exactly remember when I'm talking to you next, but I know it's at least one time next week off the top of my head, so we'll chat soon nonetheless.